84.3, the exercises. So we're going to look at one problem at a time. This one wants us to expand to 4 terms. The way I would recommend to do this is by a long division. So this one over here, if you look at it, it's 1 plus 2x, and I'm dividing that into 3 plus 4x. What times 1 gives you 3? 3. What do you get? 3 plus 6x. Subtract. You get minus 2x. What time 1 would give you minus 2x? Minus 2x. Minus 2x, and then you get minus 4x squared. You're going to subtract, so you get 4x squared. Let's see. What times 1 would give you 4x squared? 4x squared. What do you get now? 4x squared, and then you're going to get 8x cubed. Subtract, so you get minus 8x cubed. All right. What times 1 would give you minus 8x cubed? Minus 8x cubed. By the way, this goes on forever, but they just wanted to get the 4 terms. So I'll put dot, dot, dot here. All right. So let's look at the key and see if we got the right answer. And the right answer is right over here. 3 minus 2x, 4x squared, minus 8x cubed, and they go on. Now certainly, I'm going to go to the whiteboard to explain the formula one. All right? Let's go to the whiteboard and do that. I got to get to the whiteboard. Just give me a moment to do so. I got to find the whiteboard right over here. And let me, I'm going to get a new whiteboard, get rid of this one. And let's do it. So I got to open my document on my computer to take a look at it, because I can't remember what was there. And let's take a look. And this is number 1, right? Let's take a look. I got to scroll back in my document. It's a huge document, though. Even a couple page scrolling, it just seems endless document. So let's write down. So I'm going to write down the formula we want to use. We want to use a formula. Sorry about that. We want to use this formula here, which is geometric. It's 1 plus u squared plus u cubed. I actually find this easier to do than division. But I'll write this down. I don't have that form yet. What do I have? I have 3 plus 4x over 1 plus 2x. Well, I got trouble immediately, and I'll tell you what the trouble is. I need 1 term on top, 2 terms on bottom. Well, that's been cured. I want the coefficient on top to be 1. Okay. I want the bottom to look like 1 minus u, so I have to write this as 1 minus a minus 2x. 1 minus a minus 2x. All right, I think we're good to go now. What do I have here? 3. We're just going to do this one first. All right, it's fairly easy to write down. However, most people need practice doing it. What are you going to get? 1 plus u, that's a 2x, plus that u squared, plus that u cubed. You get the idea. I could write that down all day long. All right? Plus 4x times the exact same thing, by the way. We're going to get 1 plus minus 2x plus minus 2x squared plus minus 2x cubed plus yada, yada, yada. It goes on forever. All right? Now, someone says, what do you want to do with that? There's a lot of things you could do with it, but I kind of want to peacefully go through what it would look like to me. All right? So it looks like 3 minus, I'm not going to do much multiplication, by the way. It's going to be 3 times 2x, and then it's going to be 3 times 4, I'm sorry, I shouldn't put 4 down. So I'm going to say 2 squared x squared minus 3 times 2 cubed x cubed plus 3 times 2 4 x 4 plus yada, yada, yada. By the way, I put a plus down, I'm not saying that the sign is there. I'm just saying there's plus something. We're adding things on later on. So what I'm going to do now is, I kind of see the pattern there. And I want to put the bottom one down. And what's the bottom one going to be? Well, it's going to be 4x. And then it's going to be plus 4. Well, not plus, is it? It's going to be minus, isn't it? Minus 4 times 2 x squared. And then we can get plus 4 times 2 squared x cubed. And then we get minus 4 times 2 cubed x 4. One thing I like about writing this down over here is that I definitely see a complete pattern in the problem now. And so if I were to write that down, I'm going to use what's known as summation notation. If it's bothersome, don't write it down. Just simply, well, you know what, I'll just write down what I'm seeing over here now. And they just want 5 terms, right? But I'll put a sum down later. That's minus 6 plus 4, which is minus 2x. Well, this is arithmetic, right? So you get 3 times 4 is 12, minus 8, which is plus 4, x squared. And you get here, you get minus 24 and 16, which would be minus, give me 1 second, I got a message coming in, minus 8x cubed. And let's see, 1, 2, 3, 4, we have one more term, right? 16 times 3, I gotta write this down, that's 48, and 8 times 32, and that's going to be what, 16, right? Write that down, 16x4, and yada, yada, yada. All right, let's get a red pen out, and I want to see if I did good on that. And I'll get my red pen out. I'm going to look at the notes now, where they said the answer is 3 minus 2x, got that, 4x squared, got that, minus 8x cubed, and plus 16x4, and then adding something on. Again, I'm not saying the sign is positive. I'm just saying they're adding things on at this point. So I want to go back to the summation notation. All right. If I do that, I'm really kind of focusing in on terms over here. All right. So I'm gonna, let's see what I can do over here. I just write down it equals 3, and then what I'm gonna do is plus a sum. And I want to focus on really simple things, by the way. All right? So what I'm focusing in on is there's definitely every term that follows has some pattern. And I'm looking for the patterns in the groups. I'm looking for the patterns in the groups. Let's just, carefully, really carefully look at it. So I'm going to say there's something to do with the number 3, something to do with the power 2, a number 2, and something to do with a 4, right? And I know there's signs there. Don't worry about that. I know that. And a 2. And it's going to be an x over here. Right? Now, granted, I'm not saying that's it. But what I want to do is look at one thing at a time, and I'm going to start counting. So the first thing I notice is that it's something to do with a power on this over here. So I'm going to say j equals 1 off to infinity. I want to tell you what we just covered there, which is not the whole story, by the way. What we just covered there was we got this part covered. X squared, x cubed, x4. There's a problem here, though, and I want to point out what the problem is. It seems to be alternating back and forth, plus, minus, all right? Which is somewhat problematic, by the way, all right? But I'm going to say over here, and I'm going to put this down for you. I want to see if I get it. I'm going to say that this is actually minus 2 to the j. And let me see if I get that. Well, I certainly would get minus 3, because if j is 1, I get minus 3 times 2. And then the next one would be this one, because if I do if j is 2, there'd be no minus sign. That would be negative. So you'd be working out okay. And this would be that over there. So you're like 1, 2, 3, 4. All right? Now, I'm going to go to the next guy up there, and that's something to do with j minus 1 now. All right, j minus 1. I'll clean it up in a second. Let's see. J minus 1. Oops, made a mistake. Get my eraser out. I just noticed it. Again, if you're intended for this, don't worry about it. It's not required. I'll clean it up momentarily. So you got minus 2, j minus 1. Well, if j is 1, j minus 1 would be 0. Minus 2 to 0 is 1. That works. Let's see. The next one would be minus 2 to the 1. Yeah, that works too. Yeah, that works beautifully. All right? I'm going to clean it up just a tiny little bit. All right? So this is equal to 3 plus the sum j equals 1 to infinity. 3 minus 2 to the j plus 4 minus 2 to the j minus 1 times x to the j. Now, by the way, they did not ask for that. What did they ask for? They asked for up here. If you're getting there, that's great. I want to go back to the key, though. As I do that, I want to point out the only reason I'd want to write something down like this is probably to graph it out. And you might be shocked by that. If I'm going to graph something out, I'd much rather graph out the sum than I would have to type all those terms in there. All right? So let me go back to the actual document, and I want to go through that with you. And what I'm doing over here is that I'm plotting two things. And I want to tell you what I'm plotting over here. I'm plotting the 10th degree approximation, right? The 10th degree approximation. Let me get my pen out again. Which is this over here, with the actual function. This is the function. And I want to claim over here that this thing is only valid when the absolute value of u is less than 1, which means the u is between 1 and minus 1. All right? And believe it or not, this one over here only is valid is when, well, the u in this case is really the 2x, so it's only going to be valid when the x is between minus 1/2 and 1/2. That's the only place it's going to be valid. Okay? Other numbers not going to be valid. All right, so what I want to do is I want to look at the graph, and I want to kind of indicate that to you. This graph, and I'm telling you, I'm graphing both of these guys out, and let me tell you what this is over here. This is the graph of y equals 3 plus 4x over 1 plus 2x, and this is the graph of y equals, it's the other section of it, by the way, 3 plus 4x over 1 plus 2x. And this magenta color curve is that f of x polynomial I'm going to get you, which is the 10th degree approximation over here. I'm not going to write that down, by the way. I'm going to get my ruler out, though, and I want to point out when I get my ruler out, I want to just tell you that it doesn't seem to be valid outside of this region over here. All right? I'm going to mark that down for you. I'm going to go over here and mark this down for you. Get the ruler out of the way. It says, I wonder what those numbers are. Well, we just discussed it. And what I'm going to say over here is that this guy over here is really just x equals 1/2. And this guy over here is x equals minus 1/2. Now, your concern might be, let's say I did f of x to a higher degree. It's never going to get outside that range between minus 1/2 and 1/2. All right, what I mean by that, the fit of it would ever be. Look at the fit over here. The fit in this side is really good. The fit over here, it is getting really bad over here. I mean, it's shooting straight up. All right? Be aware of that. The fit only fits on a band. If we took it out further, though, let me get my eraser out. The higher and higher this degree goes, the better the fit would become in this region over here, but only up to 1/2. It's never going to exceed that 1/2 thing. All right? Thank you.